In this video, you are going to learn about the formula mass, or sometimes called formula weight. Let's talk about different types of compounds or molecules. For example, as for metal, a piece of metal actually is just a collection of metal atoms. We cannot say here is one molecule. No, we cannot say that. For example, if we break up this piece, then we have two pieces of metal. As for binary ionic compound, it is a very similar idea. For example, if we have sodium chloride, it doesn't mean that it only have these two bind together. A piece of table salt, sodium chloride, it actually consists of sodium, that's the cation, and there will be a chlorine anion next to it. Over here, there's another one. Over here, another sodium, and build up on and on. So it is not a discrete molecule. However, if you look at a water molecule, it is different. It is a discrete molecule. That means we can just bring this molecule and move it somewhere, and still it is one molecule. Now, if we try to find the weight or the mass of this molecule, we call that molecular mass. That means the mass of this molecule. As for the ionic compound, because it is not a discrete molecule, and therefore we usually call that a formula mass. That means it is the mass of each atom in that formula, the sum of the atoms in that formula. Okay, so let's look at some examples. For example, over here, the molecule is discrete and it's CHCl3. If you look over here, the central atom is carbon. Let's say the green one is chlorine, and the white one over here is hydrogen. What I'm going to do is I would like to calculate the molecular mass. That is the mass of each atoms add together. That is the molecular mass. How do I know the mass of each atom? Well, from a periodic table. This one, for demonstration purpose, I left out the central one here. So let's look at this one. Hydrogen, it says 1.008. What is this unit? This unit is called AMS, atomic mass unit, AMU. Okay, so let's look for a few, because you will be using a few of them throughout the semester. Let's look at carbon. Carbon is 12.01, nitrogen is 14.01, oxygen is 16.00. Again, the unit will be atomic mass unit, AMU. So let's go back to the previous sample over here. So we copy down the numbers from the periodic table. As for carbon, the atomic mass, that means the mass of the carbon atom, it is 12.01 AMU. The atomic mass for hydrogen is 1.008, and the atomic mass for chlorine is 35.45 AMU. How do I add them together and find the molecular mass? Over here, hydrogen, I have 1, so hydrogen have 1, carbon I have 1. However, chlorine I have 3, so I have to multiply by 3. Atomic mass multiplied by 3, I got 106.35. And I add up the weight or the mass of all the atoms. What I get is 119.37 AMU. So this one, it is called molecular mass. Very often, people call it molecular weight. All right. Let's see if we can work on some examples. Over here, let's look at it. Number 1, the formula weight of a substance is the same as the percentage by mass weight. determined by the combustion analysis? It's the sum of atomic weight of each atom in its chemical formula. Yes. So the formula weight or the molecular weight, it is the sum of the atomic weights of all the atoms in that molecule. Okay, let's look at this one. The formula weight of calcium nitrate. How do we calculate the formula weight? Remember, the formula weight or molecular weight, it is the sum of the atomic weight of each of these atoms. That means we need to look for the atomic weight for calcium. We need to look for the atomic weight for nitrogen. And we need to look for the atomic weight for oxygen. From previous periodic table, we find out that oxygen is 16.00 AMU. Nitrogen is 14.01 AMU. Let's see what calcium is. It should be around 40. Let's check. Calcium, it is over here, is 40.08. So we need to write that down, 40.08. Now, how many calcium atoms are there in this molecule? So this one is Ca, NO3, and two of them, like this. And therefore, there is only one calcium atom. So I have 40.08. How many nitrogen atoms? There is a 2 over here. These 2 would belong to both the nitrogen and the oxygen. How many oxygen atoms? It will be 2 times 3. That will be 6. So as for nitrogen, I have 2. 14.01. I have to multiply that by 2. And as for oxygen, it is 16.00. I have to multiply that by 6. And I add up this number. So let's do it. It will be 40.08 plus 14.01 times 2 plus 16.00 times 6. What I get is 164, around there. Okay, and therefore the answer is B over here. All right, let's try another one. Let's look at problem number 3 over here. What is the formula weight for lead nitrate? Okay, the principle is similar. So we are going to write down the atomic mass for lead, that is Pb, nitrogen, that is 14.01, the unit will be AMU, atomic mass unit. Oxygen will be 16.00. I find this number from the periodic table. So let's look for lead, that is Pb. Pb is over here, it is 207.2, 207.2. So let's write that down. That is 207.2. Now we are going to do the similar calculation. Within this molecule, how many lead atoms? Just one. So I have 207.2, 207.2 times 1 plus nitrogen 14.01 times, within this molecule there are 2 nitrogen atoms. Within this molecule there are 6, 2 times 3, 6 oxygen atoms. So let's see what we have when we add this up. 207.2 plus 14.01 times 2 plus 16.00 times 6. What I get is around 331 AMU. Okay, good. Since when we calculate for the molecular weight, we use the unit AMU. Although I keep saying AMU stands for atomic mass unit, but to many of us, we don't have any idea of what that is. We just know that it's a unit. So in the laboratory, we know that to measure something with our scale, very often we use grams. Well, the SI unit is kilogram, but in the chemistry lab, usually the scale shows the unit of either milligram or grams. The gram is very popular. So how do we use a more familiar unit instead of using atomic mass unit? So that comes with a new unit is called mole. The definition of a mole is we try to match this atomic mass unit. So for example, if one atom of oxygen, it is 16 AMU, atomic mass unit, and therefore 1 mole of molecule will be 16.00 gram. So there is a certain number in that mole, and it just turns out that it's called the Avogadro's number. It is 6.022 times 10 to the 23rd atoms or molecules in a mole. So instead of telling you how many atoms or molecules, from now on, very likely you'll hear about how many moles of atoms or molecules, because that will match with the unit of grams. That's what we can measure in the laboratory. So this number is very big, but don't worry about it. It is just a conversion unit. For example, in daily life, sometimes we heard about the unit dozen. So what dozen means 12. Okay, so in this case, 1 mole means 6.022 times 10 to the 23rd power. That many atoms or molecules. All right, so let's do it this way. If I have 1 mole of oxygen atom, how many grams would that be? It will be 16.00 grams. In other words, atomic mass, we can put it as for oxygen, it will be 16.00, either put in AMU, atomic mass unit, or we can say it's 16.00 grams per mole. Okay, let's try to calculate the molecular mass or molecular weight. Let's say CO2, carbon dioxide. I would like to know what is the molecular mass for this molecule. Okay, so let's look at carbon. Carbon, it is 12.01 grams per mole. How do I know that? Well, I look from here. All right, oxygen, we have seen that before. Oxygen, that's 16.00 gram per mole. So what will be the molecular weight for carbon dioxide? It will be 12.01 from carbon times 1 plus oxygen 16.00 times 2. So what I would get is 12.01 plus, I get 44.01. 44.01. What will be the unit? The unit will be gram per mole. Okay, let's work on another exercise. Let's say if I have 20 grams of water, that is H2O, how many moles of molecules and how many molecules? Okay, in order to find out how many moles, I have to find out the molecular weight of water first. And that is, for atomic weight of hydrogen, that's 1.008 grams per mole times 2, these two I get it from here, plus oxygen, that is 16.00 gram per mole. So if I do that, multiply by 2 add 16, I get 18.016 grams per mole. All right, so how do I convert 20 grams into moles? So I start with 20 grams. The grams should be in the bottom in order to cancel out the unit. It will be 18.016 grams per mole. So if I do that, the units can be canceled out, and what I get is 1.11 mole. Now, if I want to know how many molecules, I need to multiply that by the Avogadro's number. So this one multiplied by 6.022 times 10 to the 23rd power. What I would get is 60.69 times 10 to the 23 molecules.